И започваме с първата презентация на деня. The first presenter today is Sheen Brisals, and he will tell us more about enterprise serverless scale of measure. You'll learn a lot about using serverless in the enterprise environment. Sheen is a distinguished AWS hero. He is a distinguished author of books for O'Reilly. He makes presentation all around the world. So yeah, let's welcome him, Sheen Brisals.
Thank you. Thanks. Good morning. Thank you so much for being here. An amazing crowd. I was just looking at the seats and people standing. It's so amazing, so amazing. And also thank you to the organizers, sponsors for inviting me, for bringing me here. So it's my first time in Sofia. I tell you the story. I think 30 years ago, when I started flying, so when I made my first trip to Europe, I'm originally from India, but now I live in the UK. So, the flight maps used to show the locations. I always used to see Sofia on the map. It's because there's someone in my family also with the same name. And we used to joke around, I've been to Sofia. So I'm so glad after all these years, I'm here today in Sofia. So my name is Sheen Brisals, and as introduced, I'm one of the AWS Serverless heroes. And also, I co-authored a book on serverless development, mainly focusing on the enterprises and how they should, adopt serverless. So it's not a book that will teach you to write Lambda functions and deploy to cloud. It's more of best practices. How do you structure your teams? How do you architect? How do you bring in patterns, sustainability, and those sort of things? Okay. Now, I must warn you that there is no Gen AI content in my talk. This is pure, authentic. Thank you. Thank you. Yes. So, before I start, how many of you are new to serverless? Okay, so that's encouraging. Many of you know. But I will touch a few things on serverless, but please, find me after the talk if you want to know more about serverless and how to kind of adopt. So my legacy is I've been in the industry for over 30 years. I entered as a software engineer. I've been through so many different tech areas back in those days, doing C, C++, Java, etc., etc. The last 8 years or so, I was working for the Lego group, the Lego bricks. So that's where I got to know AWS and serverless, because we adopted serverless for parts of the organization in a big way. So if you go to lego.com, the back end of the entire lego.com operation runs on serverless. There are no servers at all microservices. There are so many teams working on different features, all doing serverless, all serverless services. So that's where my learning and the experience with serverless came up. And then I started to share those via articles and talks across, around the world. So that's the reason I'm here and talking to you about serverless and also relating to enterprise. Now, scale. As I mentioned, my first language is not English. As in many words in English, scale also has different meanings, right? One way of looking at scale, if you ask a school child, they will say that it's for measuring, scaling or measurement. Or if you ask modern cloud today, if you ask anybody from AWS, they'll say auto-scaling or high scale and those sort of things. So usually, when we think of enterprises, we can bring these two things into one place. So there is a measurement how the enterprise is ready for adopting serverless. And also, when it comes to the scale of an enterprise, it's more of a different word, the magnitude. So this is where we often see the large-scale enterprises. It doesn't matter which industry you belong. It is vast. And then you have the modern cloud scale or hyperscale, the way we measure things. So basically, when we look at enterprises usually have different applications of various types, modern to legacy, and it has so many products, whether used internally or for customers to consume. So that's the reason why enterprises are kind of often, treated, specially. How many of you consider that you work for an enterprise? Okay, quite a few. I mean, the reason is there are things different when you compare an enterprise with a startup. That's basically the reason why we stress this. Now, when it comes to adopting a technology to an enterprise, whether it is serverless or cloud, there are certain measurements or measures that we need to take. We can't simply jump in with the technology and ask everyone to, go serverless or go cloud and things like that. So that's one of the reasons why we need to give enough importance and assessment or measures before we dive deep into, a particular technology. So when it comes to enterprise scale, there are so many aspects of an organization. For example, take people. These are not just engineers. There will be stakeholders, there will be leaders, and then there will be customers who work with enterprise. Technologies, as I mentioned, you have mainframes or legacy to modern AI and all sorts of technologies. So as you see here, that's the complexity enterprises deal with. Even policies, GDPR or various other constraints they need to comply with. Now, when it comes to the needs of enterprises, you often see all these abilities that they need to come up with, fulfill. Scaling or recoverability and all sorts of things, especially in the modern way of operating with cloud. You might hear sort of, certain pundits out there saying that 90% of companies only need one server to, operate. The thing is, I don't think they would ever kind of, become responsible for such an organization. Because the two most expensive things for an organization or an enterprise that trades online, one is cost of engineers or people, salaries. The second most expensive thing is outages. If your business went down for a minute or for an hour, that will have a huge impact. Think of, the big online retailers. What will happen? This is the reason why we think of redundancy. If something went down, something else comes up alive. And that's the reason why we need to have all these abilities in place. So there is a reason why enterprises, take care of all these things. And then on the other side, with all the modern development practices, we are not operating like in the past with a waterfall model where once in a week, once in a few weeks or a month or a few months, we are not releasing. We are releasing multiple times every day. So that means we need to have the practices and patterns to cope with that. What will happen if a release, broke something, customers can't pay for you, whether you need to make a decision, roll back or fix forward. So you constantly kind of, monitor, observe, and then, make things better. So these are the reasons why enterprises are, special category of beasts when it comes to technology adoption. So if you think of cloud serverless, especially serverless, the first measure or assessment that needs to have is the serverless mindset. You might have heard this term mindset plenty of times. I will give you, the details in kind of 4 steps. First one, the understanding of the characteristics of serverless. These are the, the properties, how serverless works and what are the kind of parameters. And then what can you do with it? What can you do? How can you make use of those characteristics to make better solutions for you? Then understanding the constraints of serverless. This is an important aspect. Many organizations get it wrong. You need to understand what are the limits, what can I achieve? And then the collaboration. I will get to that later on. So in terms of characteristics, so most of you should be familiar with many of the, the essentials of, serverless. Of course, there are no servers for you to, manage and deal with, and you pay for, what you use in most cases, or the pay for the, storage, auto scale, etc. And these are all good. So these form the basis or basics of the serverless compute, or the serverless, the different, the services. Now, using these characteristics, then we can think of the capabilities that serverless brings. So this is becoming more interesting. You can optimize your applications in a granular level the way you want. You don't need to kind of set one set of parameters or scaling options for everything. Then you can go deeper. You can just fine-tune one function from the next one, or one queue from the other queue. They can all be different the way we want to optimize. Now, for me, the two important aspects are, it's the best technology available now for iterative development. So most of you should be familiar with iterative incremental development, right? So you work with a, 2-week sprint, you take a ticket, you push that to production. So that means you're not buying, hey, AWS, give me 100 Lambda functions, or give me, 300 SQs. No, we don't do that. Instead, we just consume as we roll out a new feature or a new update. So that's the, the benefit of the iterative development. And the other important aspect is the diversity of teams. So these days, engineers working in cloud, depending on how your teams are structured, they are not just programmers. They may come with Java, JavaScript, Rust, whatever. But then they learn the security aspects. How can I secure these services? How do I give permission? They understand, how do I queue? What does it give me? Buffering, NoSQL, and all these aspects of building a cloud scale application, they need to understand. So that's why I always say, it's a good thing. It's not a bad thing that you are just focusing on one thing. That is how the teams better operate nowadays. So considerations, this is an important aspect of adopting serverless. Big companies get it wrong and blame on technology. For example, you must have read the Prime Video story, how they moved away from serverless to doing containers and things, because they blamed on the cost and things. Why? Because no one estimated or assessed the constraints of serverless. So though we say limitless, there are limits. Okay? So there are quota, how much you can invoke a particular service per day or hour and things like that. Of course, there are ways you can ask AWS or cloud provider to raise it, but that understanding should be there. Cost. Before you jump ahead, have a brief approximation of cost. Understand how it will impact. Then think whether a different service or re-architecting the solution will benefit. So all these understandings and realizations should be part of the assessment or the measure of adopting serverless. So when it comes to collaboration, these days, it's more of a socio-technical thing. What I mean is, if you're not familiar with the term, it's not purely the technology or the engineering. Nowadays, it's a collaboration between people, engineering, and everything else. So that means you are a software engineer. Who do you build solutions for? Your stakeholders. They are not technical people, but they become part of the equation. So this is also called a system thinking. So if you read this book, Learning Systems Thinking, there is this beautiful way of saying it, because systems thinking is making you think outside the box and making you think all the interconnections and different systems, because distributed systems are all over the place. You need to have the overall understanding. And by the way, with the O'Reilly month free trial, you can actually read this book online. So my way of representing this is I call it as a serverless ecosystem. So because serverless ecosystem contains all the serverless services and the characteristics I mentioned earlier on, then we as engineers come in who use those services to build solutions for the stakeholders. So they come in, the business people come in. And in between, there is the cloud provider. So that's the foundation. So that's why I always insist that when you bring serverless into your organization, think it's as a package, as an ecosystem, not just look at a Lambda function or a DynamoDB table. Think beyond, because that realization or the understanding should be there. Reason is because when we build cloud serverless applications, our thinking also need to change. Because we are not building applications in the traditional way. We are basically bringing different managed services and knitting with infrastructure as code and deploying to cloud. Cloud takes care of most of the things, but still we need to provide our business logic as part of the implementation. Okay, so that's the mindset. So the next thing is something not many people think of is the first principles of adoption. Anyone familiar with the first principle concept? Okay, so first principles is nothing related to serverless or cloud. It's a thinking or a thought process. When you handle or when you deal with a complex problem, you think of finding the fundamentals or the primitives of those, the problem. So that means when you get to that level, it becomes easier for you to bring innovation on top of those primitives. So for that, we need to understand what are those first principles before I jump into doing a cloud adoption or a serverless adoption. There are a few things that we can think of. So when you think of serverless, you hear the term serverless first, right? This also confuses many people. People think that serverless first mindset is, okay, here is a requirement, here is a feature I need to develop. I must do in serverless. No. Serverless first does not mean serverless must. Serverless first, in the sense, is evaluating serverless to see how innovation can happen in your organization and how can you make use of the technology to build solutions faster, because we are offloading most of the heavy lifting to the cloud provider, AWS, so that we can focus on what we need to do to bring value to the business. So that's the way of thinking. So Dave Anderson's Flywheel Effect book is a good example. So if you are into Wardley mapping and serverless, this is a great book for business people and engineers as well to read. So what are these first principles? Domain first, domain-driven design. That's where we start. Team first, I'll get to that, team topologies. And APIs, microservices. You can kind of interchange microservice APIs the other way around. Event-driven architecture. Then bring serverless in. Okay? So when you have all those principles kind of considered and understood, it becomes easier for serverless to come in and thrive in an organization. I'll go in a bit deeper. So let's say domain-driven design. How many of you read this book? Yes. Okay. Or any of the other books that teach you about this book. It's a wonderful book, but I know for modern engineers, this is a bit difficult to understand because it's more than 20 years old now. Anyway, what it gives us is a way of identifying an enterprise or your organization into domains, business domains. So in some cases, the business domains vary. Some organizations operate in one domain, say insurance, for example. That's your domain, or retail or e-commerce or whatever. So then you think of breaking it down. So that means subdomains. And you identify what are the divisions within my main domain, or what is my core domain, what is my core part of the business that I want to protect. So you are slowly breaking it down. And then what it brings is something called the bounded context. So bounded context is basically a boundary within your subdomain. So you've broken down, say, insurance to, I don't know, quotes, raising a quotation. So then you identify a boundary within that subdomain where a particular model, I mean the software model, applies. So if you take that model and to put somewhere else, it won't fit there. So that's why there is a kind of cohesiveness within that area. So what that allows is to bring in the next pattern, which is team topologies. So this is relatively a new book, I think 4, 5 years old, maybe. It teaches us good way of structuring teams. Has anyone read this book? Just one. Okay, so more learning to do. I'm also, by the way, a team topologies advocate. I'm not talking just because I'm an advocate, because there are good things in this book. Now, how it helps. So we got to the boundary. Now we need engineers who can work in the boundary. So now you can assign team ownership to this small area of your big domain. So this is where team ownership comes in. So for example, when you have a feature team, you'll be kind of developing payments, for example, payment service. So that's your area of interest. So you will have a team that will own that area. So they become an autonomous team with the ownership responsibility for that small part. So those teams can be called as stream-aligned teams as per team topology. Or you can say that that's my feature team or a product team. Depends on how you deal with. And then you have enabling teams. Enabling teams are the teams that help other teams to thrive. For example, they don't do the work for the other teams. For example, if you must all know CI/CD pipelines, right? So the enabling teams could be the teams who set up all your pipelines so that the other teams can make use of. Or they introduce a different tool to the organization. So they do the work and then they promote to the other teams. Platform teams, for example, as you're all familiar with cloud, you can think of the cloud platform team who will kind of do the provisioning, control policies, and all sorts of things. But in an organization, that platform team is not just a cloud team. If you have a, say, HR system, human resources system, it can also be thought as a platform, because you make that platform easy for everyone else to interact with or make use of it. You don't need to kind of send thousands of emails to people, wait for days. You make it self-serving. So that also you can consider as a platform. So anyway, so that's the idea of a team topology, is how you structure teams. And then you bring in the next interesting bit, and that is this one. So if you are familiar with this one, microservices. So let's go back to the picture. So we have this. It now becomes easier for you to develop microservices, or for that matter, any other application that lives within that boundary. It doesn't need to be microservices alone, right? So that's the point. So now you have a team that owns that small area. They deal with those microservices. And now you can think of, okay, that microservice has an API interaction, or it sends out events, event-driven. So these aspects come in. How do you now implement? You can use serverless services. See, this is the reason why I said, before you jump in serverless, understand all these things, keep this structure in place, it becomes easier. Right, so as I mentioned, communication. When you have services, they must communicate. Contract, communication, common things. Synchronous, asynchronous communication, most of you must be familiar with. So when it comes to contracts, APIs. Again, it's a familiar term. And events, messages. And then you bring in the different patterns. Orchestration. Orchestration is, if you're not familiar with orchestration, is basically from the orchestra, where there is a conductor who will instruct, okay, violins now go, or drums come up. So they orchestrate the different parts of an orchestra. So if you are familiar with AWS step functions, That's an orchestration service, basically. Choreography, on the other hand, it's about dance movement. So there's nobody instructing dancers to dance this way or that way. They all know the steps to make. When the music is played, they just perform according to their, their steps. So in an event-driven architecture, choreography is what services like Event Bridge or your Event Bus, those sort of services bring in, because when one service emits an event, goes to the bus, and another service from a different domain and bounded context consumes that event, and that service now knows what to do with this event. Nobody is telling it, it knows. So that's the choreography pattern. So if you bring all the things that I mentioned, this is a simple representation of your domains, your subdomain, your boundaries, and how they can all interact in a happy serverless ecosystem. Right, so that's done. How do you measure next one? The serverless. This is an important aspect. Suitability assessment. Is serverless suitable for your purpose? So again, an important aspect, because enterprise challenges, as I mentioned, or different or vary across organizations. They have complex logic. I was speaking to a couple of days ago to a UK government organization. They're still migrating things from mainframe DB to database to cloud. So these are the the various technologies organizations have. Then on top, they have people problem, because there are different types of people, distributed teams. They don't speak the same language, and they are siloed, and they haven't got the cohesive way of communication things set up. They all kind of different skills, and they still in C, Java to all the Go, Rust, that sort of thing, spectrum. So this is, recently in my one of my readers of this book, my book basically, he gave me this feedback. Because this guy is so good at cloud and serverless, but he was so disappointed that his organization wasn't ready for serverless. And the mindset is not there to think something new or for better. So that is the reality of many organizations. So to tell you the truth, this guy left the company, actually. He now works for a different company. So you can think of, the capable engineers, they will kind of, hang around for a while, and then they say, no progress, they just move on. So that's important. Now, this is always, you get the sales pitch, right? Serverless, yeah, magic, silver bullet, do it, you're through. But that's not the case. Often, companies end up doing this. The typical, the round hole, square peg problem where things won't fit. You try to, you get the heaviest hammer and, bang it. Don't do that. So this is why there are three things that you need to basically understand when you bring in serverless. Will this application work better? Will it be cost effective? And if someone like me or Daniel or whoever is asking you to go to serverless, you need to think, is this guy really biased, or is it giving an honest opinion? Okay, so the first two are important. So efficiency, when I say efficiency, you might think, oh, latency. It should be the absolute best latency. No. These days, the definition of efficiency varies. So I'll give you 3 examples from the book, actually. I have a few more in the book. So I call this way: end-to-end efficiency, part efficiency, and deliberately making it inefficient. To give you an example, end-to-end efficiency. So you are looking for a price of your cloth or whatever online. You are there waiting for the the website to come back with the response. That's an end-to-end efficiency, because that needs to be absolutely the fastest possible way to do. That's the latency matters, because otherwise you'll just go to the other website. Now, when it comes to part efficiency, think of a situation you are going through that, you're buying something, you submitted the order. Until that point, the website is interacting with you, and the performance should be top-notch. Once you submitted the order, yes, they need to kind of deliver it to you within their committed time frame, but they can relax a bit as they, validate the order, as they take it through to, a fulfillment process, stock checking, things like that. So you don't need to, you don't need to spend that kind of the energy or the service capabilities you provide at the front end when you deal with this sort of, situation. So that's why the part efficiency comes in. So deliberate efficiency, efficiency and inefficiency. Think of these three, workflows. The top one is dealing with price changes. Imagine whatever serverless services are behind the scene, doesn't matter. That change should go as fast as possible because it will have an impact on customers. Whereas the bottom part is a product review. You are processing the product review before you, upload, add to the website. It's not critical. My review, if it didn't appear for 2 days, 3 days, or for a week, I won't be worried. I mean, I won't even check whether my review appeared after posting the review. Anyway, so the point here is that workflow, you can make it absolutely down. You don't need to, spin up a high-performing Lambda function or a fastest, polling queue and things like that. You can be a bit chilled. So that way, your cost can be low, and also the sustainability aspect will also be good. So this is an example, a simple example I know, where you can deliberately make something inefficient, but for you it's still efficient behind the scene, but for the outside, it's not. It's just slow compared to the other one. Anyway, so that should be there. Now, there are certain things that won't fit with serverless. There is no point in fighting against long-running applications beyond, say, 15 minutes, for example, the current Lambda timeout. No, we need to look for something else that can provide us. Or low level. So if you want to get down to the operating system level and do some sort of low-level programming, because you don't get a chance to see, what server or how they manage. Absolutely, there is no way we can do that. And then consistently, you require sub-millisecond performance. So for that, you probably need a different setup, like containers with, some setup. So understand these things. What's your requirement? And then comes the high memory, because if you need, I don't know how many GPUs you can get these days. If you are thinking of that sort of compute power, obviously serverless is not. So these realizations should be there. And then coming back to the team aspect, this is many organizations and enterprises still won't do. That is growing the team or engineers, because they find a cheap or a easy way of doing things. Imagine this is your organization. You are, as a software engineer, sitting in those 4 corners. They're now into cloud, serverless. What do? They don't have the skills. They don't have the patience to, train you. They hire from external consultants, right? They bring in people. They assemble a team. They come from all parts of the world. And they build the thing that you need or your company needs. Okay? Now it's done. Retaining consultants is expensive, right? So they disperse because the purpose is all. Now they see this as a success scenario. They repeat. Okay? Every time you need something, easy to bring a consultant team of externals, build the thing, they go away. And what happens to these people sitting in those corners, like, you? You just onlooker, right? You know that once those people left, you become the maintainers of these applications. So you will be looked at like maintainers. You won't get any training. This is a mistake many companies do. They don't transfer the knowledge when they bring in the experts to their internal teams. This is critical when we adopt serverless or cloud. So when there is no people growth, obviously the technology is not going to grow. So this is why if an organization is starting fresh or thinking of adopting new technologies, they need to kind of provide a good environment for engineers to thrive. They need to identify the good engineers who can learn and bring out the best benefits of the technology, for the organization. Then you have leaders or guidance. So people who can kind of guide these engineers and show them the right path or show them the guardrails and principles. So that way they, get the training and then they thrive, they bring out things, they taste the victories and they grow. And then you fulfill your vision. And then when you have a template, it becomes easier now to install new teams. You can easily kind of take engineers from one team and plant a new team so that they kind of bring up all the engineers. So this is how modern organizations grow teams and engineers. And finally, this one, cloud providers, the relationship with your cloud provider. The moment in an organization you say, we are going cloud or serverless, you hear this, right? Vendor lock-in. Somebody will always shout, how about vendor lock-in? We are now locked. Yeah, we are locked. But nobody shouted when the same organization bought Oracle database or they went to Java or C++ or whatever. They all have locking, but we never, saw that. But only when it comes to cloud, we shout. So vendor locking, if you're new, the vendor is here referred to the cloud provider, and the locking is that you use that particular service, provider services, that then you become kind of, locked to the platform. Now, this is a topic I can talk all day. I have my own views, but this is not the time. So basically, vendor locking is an organization, a situation an organization gets into when they use the components or the services of a particular provider and they get locked. Now, I don't like the term vendor when we refer a cloud provider. Vendor for me is someone who sells fruits and veg, outside the street, etc. But for me, your cloud provider, you should consider as a partner, because that mindset needs to be there, because there is two different things, the way we see. On one side, you have a vendor, partner. So with vendor, you see what they sell as products. With your partner, with your cloud provider, you see them as services because you consume the services, you consume managed services. And that realization should be there. And you bargain with your vendor, you're buying. Whereas when you work with your provider, you are kind of consuming consumer mind. You're consuming the services. There's a different way of negotiating your, the contracts and the prices rather than just bargaining to get to the price down and then, go with it. And then with a vendor, you always operate with a cost mind. With a partner, you operate with a growth mind. Having said that, it doesn't mean that you spend a fortune on a cloud provider. No, but there will be cases, instances where you will have a trade-off to say that I am okay to spend this extra on this service for this purpose because I am saving cost on my engineering or dealing with the Kubernetes clusters or whatnot. So that trade-off, if it's there, that mindset is good. And then you operate with a vendor, with a third party. You always say third party product, third party product. You don't say that with your AWS, right? Because you are in a partnership. Because both parties work together for the betterment of your enterprise. And because beyond that, if if you work with AWS, you know that there is a event management. If there is a big event, product launch or something, you work with your technical account manager from AWS. How think of how can I scale up? How many extra functions I need to provision? All these things. These are all part of the partnership deal. So serverless readiness measure, the things I mentioned, the mindset, the first principle realization that it's not just jumping in with serverless and doing something, assessing whether a technology is good for you and how can you make better use of it, and teams, growing the engineers, and the partnership model. I close with one example of an organization, an enterprise that went to serverless and thriving. You must be all be familiar with Taco Bell. Do we have Taco Bell in Bulgaria? But I saw a KFC. Yeah, same group. So Taco Bell, so they have thousands of restaurants all around the world, and they adopted serverless in 2018, and the benefits they see are huge. So basically, actually, in my book, there is a case study of Taco Bell. I think it's 15 or 16 pages, and also there is a case study of PostNL, that is the postal service of Netherlands, how they went serverless. Again, 15 pages. They, all details, what was the situation before, how they went, etc. So a couple of people who kind of made that happen from Taco Bell, Robbie, he's a AWS community builder, and his boss Vadim, and this has been their kind of catchphrase. Why not take risk, go and try something and see if it works. And to be honest, Robbie used to interact quite a lot with many of the heroes in the industry, learning from others before he took on the challenge. So their approach has been like what I mentioned, like small teams, cross-functional teams, iterative process, use something, bring in a small iterations, and you have guardrails and principles. So this is important. I usually detail this in a different talk, because you can't, even with autonomy, you can't just let everyone do whatever they fancy. You have to have guardrails. For example, post-kernel, they restrict what an engineer, serverless engineer, can provision. For example, they can't provision EC2 instances, for example. So you provide the service control policies and other things, and also bring in the practices like do a solution design before you start developing something, so that you upfront think about what you're developing. So these are the practices and patterns and principles that you follow. Then the autonomous pipeline. So I think this everyone should be familiar these days. And their advice to others. So basically, the progression over perfection. Start doing something, then keep perfecting as you progress. This, I can 100% say, this is what we did at Lego while I was there. And we started something very small, experimented something, then slowly, brought in all the other things, along with all the principles and the documentations and the tooling, et cetera, et cetera. And of course, don't do this, the Big Bang approach, that's the old legacy mindset. And reduce code. If you can reduce number of Lambda functions, that benefits you a lot. There are so many ways you can do. You can do native integration with so many services. Community, the reason why we are all here. And go serverless first. That doesn't mean that it is a must, but have that mindset. Evaluate, is it perfect for my use case, my feature. So I leave you with this one. So if you think that yesterday was legacy, you're all here today to learn. Make use of today to interact with others, learn from others, get to know them, learn what they did, how they did, and take that to your organization. Understand the technologies that will help your organization to thrive tomorrow. Thank you all so much. Have an awesome day. Enjoy the conference. Thank you. Do you have time?
If there are any questions, you can raise your hand.
Hey, this is about the cover of your book. I guess there is some story behind those two ostriches. Can you tell it, please?
Yes. So if you write for O'Reilly, you don't have much influence. You can say, I don't like certain creatures or snakes and things like that, but then they come with a suitable picture. So this, for us, they brought these ostriches from, I think it's a South African species. So because we were two others, we felt, okay, yeah, that looks fine. So that's how it happens. But I think maybe experienced authors can demand and change. But usually they come with ideas or options, and then you can decide. Yeah.
Any other questions? Okay.
Yeah.
If not, thanks again. One more. Sorry.
I also don't like the concept of a vendor that you explained earlier. But do you pay your partner to use his services?
Sorry, will.
Do you pay your partner because you compared vendor with a
Yeah,
partner?
yeah. Yes, of course. Because you pay your AWS cloud bill. Yes, of course you pay. Yeah. I'm just saying that from a high level point of view, the mindset the way of looking at. Yeah. Cost, of course, we all pay. That's why I always insist teams to estimate the cost before they jump doing something. Cost is always there. I mean, it's a huge factor. But it's just the way we think. So a while ago, I wrote a blog post. Is cost always a thing, or is convenience something new in our way of doing development these days? Because that also comes in. So that's why I said the trade-off, right? Of course, you'll be spending more on a, say, Christmas high season or a Black Friday. At the same time, you're also making money from the business. So that's how the serverless mindset will change, rather than having, the static cost of, provisioning certain containers and things like that. So that, it's a trade-off, but of course, cost is always there.
One more question.
Hello. So recently my company went through a migration from monolith to a microservice setup. However, the situation that we are currently in is that we can say that we still have, or let's call it a distributed monolith, where when we have a new feature or a service, we have to figure out a way how to coordinate a new version release for, say, 20 microservices, which at the end of the day, we can say that it complicated things. So do you have any advice on how to solve that? Or
No, I mean, it's a fair concern. I heard so many of this as well, like the distributed monolith, and it's so complicated. I'm writing a blog now where I talk about the complexity. Sometimes I mention my talk. On one side, we have the monolith, which looks simple, but it's hiding the complexity inside. On the other side, we have the distributed systems where the complexity is so visible, but internally, if you look at each of those services, if you build properly, they are so simple. Now, one way of dealing with that is proper boundary and APIs. So I mentioned my experience at the Lego Group. So we had a number of teams, all autonomous teams, payment service, the ones who take payment from from your customer, and the checkout or the loyalty and so on and so forth. All these teams operated with their own cloud accounts. They never deployed to somebody else. So they always operated in a separate account. They all had separate Git repositories. So that's kind of the true autonomy. So that means all the microservices a particular team used to deal with, it's all their responsibility. They only open up to others to consume via APIs or events or messages and things like that. So that reduced the concern or the complexity that you mentioned. But distributedness is a fact. I mean, we can't deny that. Yeah. Now, how you then have your API management platform or the documentations around how a team discovers somebody else's services APIs, that's part of the engineering team setup, how they set for the performance. So that's one way of dealing with these complexities mentioned. And also there are others. I mean, I can happy to talk after this, one or two examples. I know bad practices and things like that.
One more question.
If you could ask AWS for one more sort of serverless feature that would improve your experience, which one would it be?
Very good question.
Wow. Feature to improve the experience. I don't know. I probably would prefer bringing the, we talked about the distributed monolith and everything, making that pattern as a kind of a feature or a service so that we don't need to kind of bring all the different pieces together. And so if I want to make a service that has these things, off you go, you do it. So something, a wish. But yeah, I mean, it varies people to people. So something kind of pattern related rather than, sort of service feature.
Okay.
All right.
Any more questions?
I'm here until 5 o'clock today, so, happy to have a chat, answer. All right.
Thank you again, Sheen.